What if I told you the difference between mediocre and mind-blowing AI results comes down to how you ask? This applies to tools like Cursor, too. Now, in a few minutes, I'll share 5 prompt engineering techniques that will boost your AI interactions. These tips help you use AI more effectively and solve problems quicker. So let's dive in. In this video, we're going to take a look at some basic prompt engineering techniques. Now, prompt engineering is the art and science of crafting inputs that guide your AI systems, and in our case, large language models and Cursor. We kind of guide those to get the best results. It's like learning how to ask the right questions to get the best answers. And in this case, we're just sending prompts out and getting a response. Now, earlier, when we were using Composer, we had a very detailed, long, specific prompt. That is one of the key principles of prompt engineering. However, you also have to know when to be specific and when not to be specific. And the shortest way to describe that is usually you want to be specific. Now, when we did this Composer prompt, I'll open it up here. I have it saved as create prompt. Here, this is very specific, right? We have an objective, we have requirements. We drill down into those exactly what we want. This is being specific. So it doesn't allow for a ton of creativity when you're specific, right? If we chop this down to create a task management application in Python, it could come up with something completely different. There are use cases for both. In our case, we wanted this thing to basically scaffold out an application. It ended up pretty much building the application for us. At least a very rough version of it, but we wanted it to scaffold out an application and not get too creative, right? We wanted to just build a basic Flask app with MySQL, etc. If we want it to get creative, and think of it like poetry, right? If you tell it exactly what kind of poem to create at the end, you're going to have a poem that's pretty much like what you asked for. If you just say, write me a pretty poem about X, the LLM can be creative and it can generate things and make assumptions and do some other things. And that is also something that is kind of nice to do. So if you don't know exactly what you want, you can get some options from this prompt. Now let's look at some very specific prompting techniques. And I'm going to open this up larger so that we can see it. We're not really going to work with our code so much with this, but I'm going to do something like this. And I'll paste it in so you don't have to watch me type it. Write a function that calculates a Fibonacci sequence up to n terms. We'll hit enter. This is an example of zero-shot prompting. Now, why is it zero-shot? Because we're just going at the LLM without giving it any examples of what we think is correct. We're just saying, hey, make this thing, right? We're saying, write a function that calculates. We're not giving it any examples. We're not even telling it what language to do it in, though it's assuming Python, probably because I have app.py open. But here, we can see that it does a Fibonacci, etc. We have n, so we can pass that in up to so many terms. I've added a Fibonacci function that takes n as input, handles edge cases, returns a list containing the first n numbers in the Fibonacci sequence, and uses clear variable names, docstring documentation, follows PEP8 style guidelines. This is probably because of the rule that we put into our settings earlier, that everything has to be generated with PEP8 guidelines. And you can use this function by calling it with a number of terms you want. Right, so this is zero-shot prompting. You're just asking the AI to perform a task, not giving it any examples. Now, we can do something like this. We'll do one-shot prompting. Now, one-shot means we're going to give it an example, and we're going to say this is what the answer should look like. So we say, write a function that sorts an array of objects by a specific property. Okay, if we just type that in as a zero shot, it can come up with who knows. But here we're going to get a little specific and say, for example, if I had function sort by property, array property, implementation that sorts the array by the specified property, return sorted array, now write a function that finds the intersection of two arrays. Right, so basically we're saying, here's an example. Here's what I'm looking for you to output. Now, go and build me something that's just like the example that I gave you. Now, providing one example of the style and format, you will get a more tailored result from this. because we've already given it an answer and a format that we're looking for. And so here it's going to come back and say, first, let's write a function to sort an array of objects by property. So it does this thing that we gave an example of what we want it to look like. And it builds that. Then let's write a function to find the intersection of two arrays. Goes here, writes it out, very specific, and it looks exactly the way we want it to look, right? We are passing in parameters to this function. It's returning out values. We've given it an example of what good looks like. Now, few-shot prompting uses multiple examples to establish a pattern. So this is one of those things where you have a whole bunch of things that are already set up the way you want them set up, so you want it to continue that way. Even if it's not quite correct, right? You're just saying, this is how we're doing it. This is how I want you to generate it. So we'll look at this prompt here. Convert these requirements into just test cases, right? And so this is actually JavaScript, but that's fine. Example 1, requirement. User can log in with the valid credentials. And it says, whoop, and we have our function here. Example 2, requirement. System rejects login with invalid password. Here's the test. These are 2 examples. Now, when we've given it 2 examples, so it can take everything that's in common between these 2, it can take all the patterns and just assume this is how we do things. Now convert this requirement. User session expires after 30 minutes of inactivity. Now I'll close out the app.py and we'll just hit enter here. I'll help you create a just case. And then it creates one much in the same style of what we gave it earlier. Right? The first test verifies a session expires after 30 minutes by creating a session advancing time by 29 minutes, advancing time to the 30-minute mark. The second test verifies that user activity properly resets the timeout by creating a session, advancing time, etc. So we're getting very specific with this, and we're saying this is what our just tests look like right now. This is what we want the next one to look like. That is few-shot prompting. Here is a chain of thought prompt. Design a database schema for a social media application. Now here's where it becomes chain of thought, right? So if we just drop that on its own, then it's just a 0-shot prompt like any other prompt, design a database for a social media application. But we're adding this second element here. Think through the entities, relationships, and constraints step by step. Now, right now, there are models out there that automatically do this. So this is not needed at all. So if you say design a database schema for a social media application and you drop it in DeepSeek R1, for instance, it will think about this stuff. Same thing with Gemini, Claude. They all have thinking models now, which kind of renders these obsolete, except for the fact that that second part, right? So the second part says think through this, and then you're being specific about what you want it to think through. So it's not quite obsolete, in other words. So if we say design a database schema, and let's say we go to our models here, and we could do Sonnet thinking, then it will think about it. I don't have to say think about it. It's going to design a database schema, and it's going to think about it, and it's going to come up with something. But since I have this chain of thought prompt here that says think through the entities, relationships, and constraints step by step, we're being specific and saying, you're going to think, I want you to think about these things, if that makes sense. So when you read online and you hear people say, chain of thought prompting is gone, it's obsolete, it's out the door, because now they're all thinking models, that's partially true, except the fact that you can still use a chain of thought to tell it what to think about and guide it for what to think about. So that's why I wanted to bring up chain of thought prompting. I see it online quite a bit where people say, don't do this anymore. This isn't any good. They already think for you. You're wasting your context, etc. But that second thought, you can say, think about it and think about these things step by step. So go through here, Sonnet thinking. I'll say submit. And we can see that we have a think here that says it's thinking about something. And now it's generating my tables. And you can see it's designed a pretty large database here. So it's pretty cool. Now, once it's done, we'll go and look at it. Okay, it looks like it's done. So this is, designed a whole big SQL thing. Now look in the beginning in the think. The user has asked me to design a database schema for a social media application. So that's the very first part of it. They provided Flask application code file. So I had app.py checked. Forgot about that. But the actual request is about designing a database schema for a social media application, not related to the provided file. Then the next part, let me think step by step about what entities, relationships, and constraints. Does that sound familiar? Well, of course. Right here, entities, relationships, and constraints. So again, we're just with a chain of thought prompting. You're saying, hey, think about it. And this is what I want you to think about. I'll change this back to, we'll just go to it with a Claude 3.5 sonnet here. And let's look at the next one. Self-consistency prompting. So I will, again, copy this in so that you don't have to watch me type it. Write a regular expression that matches valid email addresses. Here's the key. So this right here is a zero-shot prompt, and it's simple, and it's easy, and it can generate tons of great answers, right? Write a regular expression that matches valid email addresses. However, here we say, after writing it, test your regex with the following examples and verify that it works correctly. So we have valid at example.com, invalid at blank, user.name plus tag at, and an example.com. So let's go ahead and submit this, and let's see what it comes up with. And it says right here. And it says right here at the top, I'll help you create a robust email validation regex pattern and test it against those examples. Here's a Python code block that implements and tests the regex. So not only does it test it, but it's giving you the opportunity to test it, right? So we can say email pattern, test emails, etc. So this basically, self-consistency is just saying, hey, test it. There are other ways to do this too. Self-consistency is kind of interesting with large language models, and we don't fully understand why certain things happen with them sometimes. But one of the things you can do with these models is say, give me 10 answers and choose the best one. That will cause it to think, and especially if you're using a thinking model, it'll cause it to think. I'm using quote marks. You can't see me, but I'm using quote marks to think about the answers. Think about the reasons each one's good, each one's bad, does a comparison, picks one of them, which is pretty cool. And so we can just modify this a little bit here. I'm going to copy this prompt, write a regular expression that matches email addresses. We're going to go here. We're going to select Claude Sonnet Thinking. Create 10 of them and evaluate the pros and cons of each. Actually, we'll just say 5. It would be really hard for it to create 10 regular expressions. They're pretty deterministic. So create 5 of them and evaluate the pros and cons of each and pick the best method. Now we'll hit enter and let this thing take off. Okay, and here we go. So we have this, and it says it's going all the way to the top. It's thinking, asking me to write different regular expressions for validating email addresses, provide 5 examples, evaluate them, and recommend the best one. And we can see that it's going through a few options here. 1, simple regex, basic format check. 2, more restrictive regex with better domain validation. 3, highly specific regex based on RFC 5322. Number 4 is immediate regex with TLD validation. And 5, using Python's email utils parse adder and email validator package. Now evaluate each of these approaches. And it goes through an evaluation of each of these. Recommendation number 5. Let's see why. Email validation using Python's email validator package. Why? Because it's the most accurate validation following standards, handles normalization and internationalized domains, maintained by experts and updated regularly, provides detailed error messages. The cons, external dependency required. not a big deal. It's a Python library, right? Slightly more overhead than a simple regex. Again, how often are we doing this? Maybe it's not a big deal. Might be overkill for simple use cases. So it does explain best options number 5, recommend using it, it's most accurate solutions, etc. If you must use a regex only approach, use option 4. So that's kind of cool. It gives you a good second choice backup there. In any case, this is so this is another cool prompting method that I wanted to show. Now, here are some general rules for effective prompting that we'll talk about here. And I will just, instead of showing slides, I'll just write this on a screen, right? Number 1, be specific and clear. This is important. Being clear is, so if you're asking another person to do something for you, the more specific you are, the more they know what to do to help you, right? You can't say, fix my car, and then walk away from the mechanic shop because the mechanic's going to say, oh, I see a broken taillight, I'll fix that. Meanwhile, the motor's broke, right? So you have to be specific and say, I need you to fix the engine in my car because it's doing this. So we take those same communication skills that we use for human-to-human communication and apply those towards prompt engineering because it's very much based on natural language processing. So be specific and clear about what you want because vague prompts will lead to vague responses. And like I said, sometimes that's okay. Sometimes you want to give a vague prompt to see how creative it gets. So what is a bad prompt would be write some code, right? And a good prompt would be write a Python function that takes a list of integers and returns the sum of all the numbers, whatever, right? So specific and clear. 2 is provide context. Now, thankfully Cursor does this for you. Say if I ask a question right now, it's going to look in rules.txt. You can see in the upper right-hand corner there, it's going to look in rules.txt. That's using it as context. I can also use my entire code base as context as well. So you're giving relevant background information to help the AI understand what the heck you're talking about, right? And so bad would be, again, fix this code. But good would be something like this React component should display a list of items, but it's not rendering it properly. Here's the code and here's the error I'm getting. Right? So that's always good to provide context. 3, we saw this earlier, use structured formats. So using things like headers, bullet points, numbered lists, things like that, these structured formats can help convey your message better. Right? And so we did that earlier in our prompt, which will open up here. We structured this and we said, hey, here's the requirements. User authentication. Here's what we expect out of user authentication. Here's what we expect out of application functionality. Here's what we expect out of task, etc. And we're basically telling the AI exactly what we want and we're structuring it in a structured manner. So this helps with complex requests. So if I just wrote out, 10, 15 sentences explaining what I want in some rambling paragraph, it's not going to be as good as this where we break it out, we make solid statements, very concrete, etc. Now another one here. Specify output format. Now this one we haven't used a whole lot yet, but you can say something like generate documentation for this function in JS doc format or whatever. And what that does is it specifies the format that comes out and you basically are saying, this is how I want it. Don't make any assumptions. It's the same thing with, say, writing a test. You can say, write a set of tests for this application. Are we using PyTest? Are we using something different? It'll make an assumption, but if you say, write this, use PyTest for results, then it will do that. So you specify the output. The last thing is iterate and refine. So this is one of those things where it's like you don't expect perfect results on the first try. We got really lucky with our giant create prompt here that it was mostly good. We only had to do a few modifications, but sometimes you have to go back and say, no, I meant X or you generated X and I want Y. And then you refine and you can go back and forth. If you've been using large language models like ChatGPT or anything like that, then you're quite familiar with this, where you have these long conversations and at a certain point, you have to either bail out of the conversation or just take what you got from it and call it good, because you can go back and forth and say, no, I want this, and no, I want this. And that is perfectly natural. And I say it's a best practice to iterate and refine. Keep trying this. And one of the things that I do that's kind of a trick is I'll go into a LLM and say, help me improve this prompt. Take a look at it and tell me what's wrong with it. And then I'll put in whatever prompt I thought I was going to put in. It'll come back and say, here, use this prompt instead. Usually end up with a better starting prompt to go with. So this is my quick introduction to prompt engineering. We'll be doing more of it. We'll be inserting some more things as we go along with Cursor. And thank you for watching. Effective prompt engineering comes down to being specific, providing context, using structured formats, specifying your desired output, and refining through iteration. Master these techniques and you'll get exactly what you need from AI every time. If you want to learn how to use Cursor as your ultimate coding partner, check out my course at KodeKloud. The link is in the description below. Let's take your AI skills to the next level.